Hello, I am making this video for you to help with lab 2. To find lab 2, which you have to do this week right here. To find the lab 2, you have got to go to the learning unit. And then you're going to go to rock fossils and time. And the assignment box, it's right here. You click on that one. And here is your Historical Geology Lab 2. I'm going to turn it into writing mode and open this lab. And here is the Lab 2. And here, the thing you have to do is that we go through the sequencing, which means we're going to have to go through the principles. The first one is the principle of original horizontality. And you know what that means. The beds of sediment will always deposit horizontal. Then the principle of superposition, that will tell you that when you see a bunch of layers, the oldest is always the one on the bottom. So this is going to be the oldest, second, third, fourth. And then the lateral continuity, if you have a sedimentary basin, each layer always fills up the basin completely. Like when you have a bucket and you pour sand in it, the sand always fills up the bucket. So it's the same situation. So if later you see any kind of river erosion or something that happened after the sedimentation, you got to know that that lateral continuity means that the whole sedimentary basin was filled up originally. So if we go down, the next one is the principle of unconformities. When we're talking about unconformity, that means missing time. So when you have unconformity, that means during that time there was no deposition. We have three kinds: the nonconformity, the angular unconformity, and the disconformity. And it's written down here pretty good, but I'm just going to show you. So if you have an igneous rock, and this is the way you show igneous rocks. Sometimes you could put X's, that's igneous rock also. And then after that, it comes with sedimentary rocks on top of it too. This boundary here, and I'm going to change the color so you understand it better, like blue. So this here is the non-conformity because this is igneous rock. This is sedimentary. And whenever you find igneous rocks touching sedimentary rocks, it's going to be a non-conformity. So that's non-conformity. Now, when you have angular unconformity, that means that you have an erosional layer, and I always show this with this wiggly line, and the layers under come up with an angle. Now, you have to imagine that this here used to be horizontal, so if you turn it back to horizontal, this is the oldest, this is the youngest layer, and on top of it, you got the next layers. So this unconformity is an angular because the layers come up with an angle here. And the last one is disconformity. When you have a disconformity, I guess I'm going to just draw it right here. When you have a disconformity, you again have the erosion surface. That means that the layers above the unconformity and below the unconformity are parallel. So oldest. And so this here is a disconformity. It comes right here, disconformity. Okay, the principle of cross-cutting is when you have different kind of happenings. Like you have the rock layer and then it gets cut through with this dike. And then that is being cut through by this one. And at the end, this is cut through by that. So with the cross-cutting relationship, we can figure out what igneous intrusion, because these are igneous intrusions. What is the oldest one? What is the youngest? Based on which one cross-cuts the other one. So the next one is the principle of inclusion. When you have a principle of, when you play with the principle of inclusion, if you have like a beach or something and you have pebbles on the beach, and the pebbles later are going to be in a layer of sedimentary rocks, you know, these pebbles have been rocks before. So the pebble, the inclusion is always older than the rock which includes it. Okay, so that's the principle of inclusion. Then you got the principle of faunal succession. If you work with fossils, you understand that the the fossils are always, if you have the same type of fossils, it always means time equivalency. So this whole area is formed at the same time because it has the same fossils. So now we're gonna have to try to start understanding the relative dating. And on the test, I have one of these figures, so I want you to understand. So here, what we got, the number 2 is a fault line. See, it's a fault line. And whatever rocks being faulted had to be there before the fault line came in. So obviously, this whole sedimentary layers had to be there. So that's number 1. Then it got faulted. And as you can see, this number 3, which is an igneous intrusion, had to come in later because it went through that fault line. See, it went through the fault line and it went through the rocks. So this was the last thing. The fault line was there and all these rocks had to be there for this to come through. And then because neither the intrusion nor the fault line went through these layers, this came later than those two things. So I hope you understand. And before we jump into the exercises, I would like you to learn the rock symbols. We're going to use these throughout the semester a lot. So the first one is the igneous. It could look like this with little triangles, or it could look like little X's, or they could look like little crosses. These are symbols for igneous rocks. Now, if you have metamorphic rocks, usually they will have these wiggly lines throughout the section, so that's metamorphic. When you have metamorphic rocks, if you remember, they form by previously existing rocks by pressure, heat and pressure. So if you have a cross-section with metamorphic rock in it, it's almost always means that they are the oldest rocks because they have been different rocks before. So these are the igneous and metamorphic, and now we're going to do sedimentary rocks. Those are the most important type of rocks in historical geology. Let's start with conglomerate. Remember, the conglomerate has the round pebbles. And if you have breccia, that is like the low angular pebbles. Then you have the sand. The sand that just usually low spots like this sandstone. Then the siltstone. Siltstone usually gonna be like this. And the mudstone will be like this. Shale or mudstone. And then the carbonates, like the limestone, will look like this. So that's limestone. And the dolomite is similar. So that's dolomite. If I remember another type of rock, then I will just show it to you later. So let's go back to a lab. Always start with the oldest layer. We can see that this T is an igneous rock. You can see the little crosses, so that's an igneous rock. And this T is going through all these other rocks. So obviously, this T came in later than these rocks. So now we can go and look at what is the lowermost layer. See this P? This P is an igneous rock. So P is an igneous rock, but there is an erosion here. So this P had to be here before these layers. So the oldest rock here is going to be P. And then there is a non-conformity right here. This is a non-conformity. I'm going to write it down. So it's a non-conformity. when you have an igneous rock meeting with sedimentary rocks, that's non-conformity. So after the P, the next layer is going to be this M. And after M is going to be the L. And after L is going to be the K. See right here? Now, after the key, see there is this line. It's a fault line. And this fault line went through all these layers, but it didn't go through this one right here. So the fault line comes after K. So that's A. And this here is an erosion, an unconformity. But because these layers are coming up with an angle, this is a so-called angular unconformity. So angular unconformity. Now what comes after A, after the fault line? Yeah, you're right. It's going to be the R. After R is the J. After J is the W. And I will continue it like right here. So after the W, you can clearly see that this T came in because it went through W, but it didn't go through B, F, or E. So we know that this igneous intrusion came in after V, so W, sorry. So after W comes T, and then you can see this is, again, an erosional surface, but it is parallel. This layer is a parallel with this layer, so this here is a disconformity. Now, if you look at the T and all these, this is non-conformity, that's non-conformity. And wherever we are here, like this area, that's a disconformity. So, after T, what comes? You write B, and then F, and E. And then there is an angular unconformity here again. And then the last layer is going to be the H. So I hope you do understand how it goes. And I hope you will be able to do the next one. Which is going to be this right here. I don't really want to tell you the whole thing, but see that we do have this metamorphic rock here. It's also M. So M here is going to be the oldest. It's metamorphic. And then there is this fault line, which doesn't go through anywhere, but just this M. So the fault line, I don't remember the name of it. Probably it's an F. I don't remember. And then we have the O. In this case, the O represents a non-conformity. Because it's metamorphic, touching sedimentary rocks. So after O comes I, and then F, and then E, and then this igneous intrusion, which is D, and then C, and then this here is L, that's an angular unconformity because these layers are coming up with an angle. And then comes B, then J, which is a disconformity, and then G, A, and see this igneous intrusion, the H, comes through everything. So that's the very last event. So I put that down for you. And I hope you understand and you will be able to do easily the last one, which is right here. And again, remember, on this section, there is a metamorphic rock again. So remember, the metamorphic rock is always the oldest because it's metamorphic, but I'm not going to help more. You can do this. So just don't forget to turn this assignment in the Dropbox right below the assignment itself. And I hope I could help you with this.